My name is Ed Stangler. I'm product manager at Bradmark Technologies. Been working on databases for a long period of time. Been doing some talks about different topics across different types of databases. We do a lot of stuff on the ASAP side for ASC and other related products, but we also do things on Oracle and SQL Server and DB2 and many other types of databases. I've been doing this for a while and hope that some of the things that we've learned in working on the various databases comes through on this presentation and helps provide a little bit of insight into how the databases work. Okay, so now we'll go and talk about SQL Server availability groups. Now, SQL Server is a database that we've supported for a very long time. We've supported it going back to pre-SQL Server 2000. Of course, we also support the latest versions of SQL Server 2017, and all of the various CUs and things like that that have been available in between. Now, SQL Server availability groups was introduced in SQL Server 2012. It basically replicates databases, so it's yet another replication technology inside SQL Server, but it's probably the one that's going to stick, and as I'll explain a little bit later. Now, of course, the heart of it is replicating databases, but the databases are organized into groups, availability groups, and they're replicated together. So it's as a unit, they're replicated. Now, this is a HA and DR solution, high availability and a data disaster recovery solution. The HA portion is built on top of Windows Server failover clustering. So it's using all the clustering services that are built into the Windows Server environment. So it makes it very reliable in terms of being able to fail over things like listeners and other types of resources. And availability groups is part of the AlwaysOn branding. AlwaysOn is a tag that's actually several technologies inside SQL Server, and availability groups is probably the biggest one of the AlwaysOn branding. But AlwaysOn is just basically the branding, and the availability groups is really the feature. Availability groups, the full availability groups, does require Enterprise Edition, though Microsoft did change things up a little bit in later versions, as we'll see. Now, this replaces database mirroring. Database mirroring is now deprecated, and really it makes a whole lot of sense because availability groups is really just a generalization of database mirroring. If you look underneath the covers and how it works, it's very, very similar to database mirroring, but it's more generalized and much more useful as well. So availability groups, in addition to doing a lot of things that it's good at, is also a partial alternative to some other SQL Server technologies that I want to call basically dormant. They're still in SQL Server, but definitely the emphasis has been taken off of them and pushed onto availability groups, especially if you look at how much availability groups has been improved in the last several versions. But these are still available in SQL Server, but AGs can replace them to some extent. I think a lot of people will find that there are features in these items in these features that do not have a corresponding item in AGs, but that list I think is shrinking as time goes on. Failover cluster instances, or FCI, is a high availability solution that basically you have an active standby scenario where one server is active, one server is standby. That's for failing over entire instances, not just the databases that are inside there. So definitely in many environments, fail over the entire instance is preferable. You get a lot more that's automatic. But it's also very limited because you have to have one active, one standby, and that kind of stuff. But that's for HA. Log shipping for disaster recovery. Log shipping is a very manual process, unfortunately, in many respects, and kind of seems like it's put together with glue a little bit. But AGs is definitely.
Uh-oh. I think his headset just broke. So log shipping is basically you take the entire log and ship it over to the
definitely has.
server. You back?
I'm sorry?
Yeah, Dad, you disappeared for a second there.
Okay, sorry. So replication is typically used for read scale out. So for example, offloading reporting onto another server. This replication definitely has a lot of moving pieces to it regarding schemas and things like that. But AGs are not 100% replacement for that, but definitely, as we'll see in a little while, the read scale-out capability is something AGs can provide. And AG provides this through different modes that are available in availability groups. You have synchronous commit mode, which is great for high availability. It makes sure that the primaries and the secondaries are very close together in terms of the data, so you have minimized data loss or have no data loss. Then you have asynchronous commit, which is great for disaster recovery. It reduces some of the restrictions on the data and in terms of guarantees and stuff like that. And for a lot of things, it helps provide another copy of data in a way that's not that's performant, but of course it can't be necessarily used for HA because of the lax guarantees. But asynchronous commit is a great thing for disaster recovery. And then also having read-only access replicas for read scale out. What this does is AGs can provide another read-only copy of data on another server to help with scale out in that sense. Okay, so in SQL Server 2016, what we saw earlier was 2012, 2014. In SQL Server 2016, we had improvements, a lot of improvements to AGs that were introduced by Microsoft. Direct seeding was a very nice improvement. Normally, when you have a replica on a secondary database, secondary replica, you have to initialize the databases by doing a manual backup and restore. Direct seeding handles that automatically. Lots of things can go wrong still, but at least it's a little bit easier by default. We also had basic availability groups that was introduced. This allows availability groups to work on standard edition with a very reduced set of functionality. And this was definitely a more direct replacement for database mirroring than the general availability groups. This was very much geared toward getting people to move off of database mirroring and onto basic availability groups. Unfortunately, there's no real way to migrate from a basic availability group to a regular availability group. So that's a little bit of an issue, but still, if you're just trying to get off of database mirroring, basic availability groups is great, especially if you only have standard edition available, whereas most of the time availability groups requires enterprise edition. They also introduced distributed availability groups, which allows you to span two separate AGs. This is especially important for geographically dispersed sites. You can easily replicate between two different sites, between two different sets of availability groups using distributed ones. And also part and parcel to that is domain-independent availability groups. So, there seemed to be a trend at that time in Microsoft to try to provide more options than Active Directory domains for handling certain types of servers. For example, on Exchange Server, they have an option to create a certain type of server in a DMZ area, for example, that doesn't require Active Directory, and it uses something similar to this. It uses DNS and certificates to get around that. So similarly, they added that to availability groups so that you can create a set of availability groups that only requires DNS and then some certificates instead of the full-blown Active Directory domain in that particular area. And especially when you have a geographically dispersed set of sites, this becomes a little bit more interesting. Then in SQL Server 2017, of course, SQL Server 2017 was the introduction of the Linux version of SQL Server, so there were a lot of things that go along with that. And one of the things I think that partially drove this was the Linux port, was the read scale availability groups. Now it's a new type of availability group that does not require Windows clustering. You could use it to provide disaster recovery, but I think that might not be the full intent of it, but it could be used for that. But primarily, it allows you to create read-only versions of databases on different servers. I mean, on an industrial scale, you can create, I think, something like 17 read-only copies of your database, whereas the normal availability groups is like 4 or 8, depending on things. So this really allowed a massive amount of scaling on the read side for availability groups. And you can use this with distributed availability groups to go across to different geographic locations as well, and combine that with not needing Active Directory. And it really is a very flexible system now for availability groups, especially if you're trying to do read scale or read scaling. And this is available on Windows and Linux. Especially on Linux, this made a lot of sense. But that's not to say that you can't use availability groups in general on Linux. You can still use availability groups, I believe, on Linux with Pacemaker or something else you do in the clustering as well. So, but Rescale was definitely an improvement. And as you can see here in the 2016 and the 2017 editions of SQL Server, Microsoft has put a lot of effort into availability groups. And it does seem like availability groups is the replication technology that is getting the most amount of attention right now from Microsoft. Certainly the other technologies could have had some of these improvements as well, but I think Microsoft has just decided to concentrate on availability groups because it provides the right kind of granularity for replication. You know, as we saw with FCI is all instance or nothing. Database mirroring was one database at a time. There just wasn't the right level of granularity, I think, for a lot of people. But with availability groups, with the ability to have multiple databases being replicated together as a unit, I think that provides the optimal granularity in terms of replication. So we see here that each node in a Windows cluster contains an independent SQL Server instance when you're configuring availability groups. These are completely independent SQL Server instances, unlike FCI, where FCI you have two instances, one's active, one's standby. They're the same kind of instance. But in this one, with availability groups, they're completely independent for all intents and purposes. Each availability group contains one or more databases to replicate together. So this is that one unit that's being replicated as a group, and that seems to be a logical unit for a lot of applications. A copy of a group on a particular instance is called a replica, and a replica can either be a primary replica or a secondary replica. So the primary one is the one where you read and write to it, and then the secondaries are being replicated to, being ready to be maybe failed over to, being maybe available as read only, those kinds of things. So as I mentioned before, availability groups is a HADR solution. So there's a high availability side and a disaster recovery side. The high availability side allows you to do failovers, and that can occur from a primary to a secondary. There's lots of caveats and restrictions. You know, they have to be synchronized, and they have to be synchronous commit, and those kinds of things. So there's a lot of things that go with that, but when it's set up and it's working, it's great. You can fail over either automatically or manually. The synchronous commit mode ensures that each transaction is hardened on the secondary. And hardened means that it's actually written to the transaction log. Part of the replication that they have, which is a very robust replication system for replicating log records, or log blocks actually, to the other systems is really, really fantastic. But until it actually gets hardened on the secondary, it can't really promise that it's going to be able to fail over without some kind of data loss. And there's different levels, I think, of data loss you can have as well, and there's ways to override that. So there's a lot of flexibility there as well, but certainly when it's hardened, you make sure you can have less data loss or no data loss during the failover. The disaster recovery side has a synchronous commit mode to provide better performance in some cases. So for example, if you have 10,000 inserts, if you commit after each insert, AGs may replicate that in a way that there may be a lot of back and forth that adds to the time, the performance time. And so in a synchronous commit mode, that might cause an undue delay in the application. Whereas in asynchronous mode, it might work a little bit better. It might provide better performance inside the application. You know, the other way to fix that would be to do the insert, let's say 10,000 rows at a time, and then commit. But you know, when you have an application, there's not much you can do about things in many cases. So in asynchronous commit mode, though, it's able to replicate things without a guarantee about whether data is synchronized between primary and secondary. So you can't actually use that for failover necessarily without data loss, but it's very great for when you need read-only access to secondaries. So if you need to provide reporting on another server, asynchronous commit mode is great for providing that read-only access to that data, or providing for a disaster recovery scenario where you don't necessarily need to have the most up-to-date data possible. So primaries allow read and write on the primary replica. The secondaries can be configured to allow read-only access. And an AG listener is something that you can set up per availability group that can route clients to different instances. The listener has its own DNS name. So in addition, just like you would connect to a SQL Server database using the name, you would have a new name for the listener. The default client connections or app connections that go to this particular listener would go to the primary, and they'd be read and write capable. But if the client were to do something special, if they indicated read-only intent, which is available through different types of parameters. If you're running SQL command, it'd be the $K parameter to specify read-only, and you have to specify a database to log into initially. If you don't do that, it's not going to work either. Then the listener can do read-only routing to a readable secondary. So in this way, you can have a lot of connections going to the primary and then having other people that only need reporting, for example, being routed to one or more different secondaries. So it really provides a great way of offloading and scaling up work. Read-only routing supports load balancing in SQL Server 2016 and, of course, redundancy. So you're able to spread the load across secondaries. And, of course, if one secondary is down, it can go to other secondaries as well. And the listener is great because it follows the primary through failovers. So node 1 goes down and it was the primary. Node 2 is only the primary. The listener will now point to node 2, and there's nothing you have to do in the application to change that. Whereas in other types of scenarios, like with database mirroring, you would have had to update the application. For monitoring availability groups, there's a wide variety of different pieces of information that Microsoft has made available. The DM views, of course, is one of the best places to go to for dynamic information. There's a couple of views that are related to the Windows clustering itself. Those are things like the DM_HADR_cluster set of views. There's instance node map, name ID map. Those are primarily related with the clustering side of things, the low-level clustering side. And then you have the availability group views, the DM header availability, DM header database. There's a little bit of similarity between the view names, so it's very easy to get confused. A lot of them have, say, database states or replicate states or replicate cluster states. I mean, it gets all very complicated after a while. But there are definitely differences in these types of views, as we'll mention in a moment. And then there are other types of views as well, such as the very interesting DM TCP listener states view that was added in 2012. That is just a generally nice view because it talks about what the ports are that it's listening on, what IP addresses, those kinds of things. There's also catalog views that have a little bit more static information available. The sys.availability_whatever views, and that has like what exactly is available, as the replicas, what groups are set up, that kind of information. I think there might actually be a little bit of dynamic info in there as well. But also one of the important things to look for are endpoint URLs as well. As I mentioned before, you have read-only routing to read-only secondaries. Those are available because of what they've created called endpoint URLs. Some of the newer features in 2017 and 2016 take advantage of the endpoint URLs to be able to implement all sorts of more advanced stuff as well. So that's a very important part of availability groups as well. And then, of course, perfmon is available, perfmon statistics. These are available through Performance Monitor on Windows, as well as the DMOS Performance Counters DM view as well. And the perfmon statistics, unfortunately, are quite important for availability groups. We're not going to go into all of them today, but there are some interesting ones such as flow control and logs flushed and some other ones that definitely can tell you more about some other types of scenarios that can occur during AG replication. And then extended events, of course, is Microsoft's go-to place to go to for pretty much everything now. AlwaysOn_health is a set of events that are, I think, out of the box that have a lot of different things going on, such as you can find out when failovers occur, when the primary changes, for example. There's also some very detailed information available for log record replication. I don't know if these are debug events or if these are regular events, but this is you can find out all sorts of information. I'm sure you could find on the internet. There's all sorts of information for finding out exactly when log blocks get transferred to here or there or everywhere, and all sorts of different things that go along with that. So there's a tremendous amount of detail, and of course, if you turn all that on in production, it will completely destroy your database. So you have to be very careful about some of that stuff as well. Now, there are a lot of caveats with the DM views, and I'll go through a couple of them here, just a couple of gotchas that we found as we were doing things with AGs a long time ago. We have a replica view that the type of replica you're on changes what you see. The DM views can act very differently on primary versus secondary. There may be rows missing on some that are available on another. So it's that's kind of unexpected at first, especially when you think you're seeing all of them on the primary, but then on the secondary should know about all those particular rows, but some of them are not there. And in particular, the joining situation is an issue that you have to look out for. On a secondary database, well, a secondary database is joined to an availability group after it's initialized. So after you've done backup and restore, or you've done direct seeding, and it's fully initialized, then you would join the secondary database to the availability group. Now at this point, the replica has been joined or added to the availability group, and so it's just the second step in order to get the database actually kind of registered. Unfortunately, the view DM header database replica states on the secondary replica will be missing rows for databases that are not joined, like that. On the primary, you'll see it, but on the secondary, they're missing for some reason. And for various reasons, you may be querying on the secondary, and so this is kind of unexpected when suddenly those rows are not there. So therefore, there's another very similarly named DM view called DM header database replica cluster states. That's probably the view to start with if you're doing queries against secondary replicas and you're rolling your own monitoring and you want to start the query and then maybe join to other things. That may be a better view to start with. Null values aggregated is another issue. If you query DM header availability replica states view, you may get this kind of warning message about null value is eliminated by blah, 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 blah. Behind the scenes, some of these views seem to be doing group buys and those kinds of things, and there are some issues that can occur from that. So this, unfortunately, this is part of the larger issue that the DM views seem to be kind of volatile in some ways from version to version and how they behave. So it takes a little bit of work, a little bit of effort to understand what's going on and how they behave on primary, secondaries, with the different types of views and that kind of stuff. On a secondary, it may not have this kind of message, but you may see this on the primary, for example. And then you also have LSNs. Normally these are log IDs, and so many of the LSN values that are shown in these DM views are updated in a very relaxed way, or maybe not even, maybe never updated. In some cases, on both primary and secondaries. And this makes it very frustrating because you would think that there'd be a lot of great things you could learn about the log records and how they're being replicated and arrival times and that kind of stuff. Unfortunately, the LSN values are just not updated in a timely manner enough for real-time monitoring in our experience, at least so far. And of course, as the documentation says, the LSN values are not true LSNs, but really block IDs, because SQL Server replicates logs really in blocks rather than one log entry at a time. So that's something else to keep in mind. Now, there are a couple of areas that for monitoring to monitor, and it's things that we do and things that you would do I think in any system where you have availability groups deployed. There's a lot of bad information on the internet, unfortunately, for calculating latency, but the Microsoft has tried to add latency calculation in the form of secondary lag seconds, which is available in SQL Server 2016. It's a good start, but unfortunately in our testing, we have found that it doesn't quite reflect the value good enough for real-time monitoring, for our tastes at least. I definitely encourage you to try it in your environment, see how it works. Maybe it's good enough for your needs, but for our needs, unfortunately, we just don't see it really updating in a manner that we expect, that in a timely manner, that kind of stuff. Maybe in the future this will be a great thing, and this will be the way we go for it. But at the moment, it doesn't seem quite to be the right fit for us. And it's not available on secondaries either, so this is only on primaries. So if you are querying for monitoring data on the secondary replicas, this is not going to be put in at all, which is kind of weird because they should know, right, the secondaries. But on the primaries, it's available as maybe a useful thing for you to look at. Unfortunately, it is in seconds and not milliseconds. So for HA deployments, you might want it in milliseconds, but unfortunately, it's only in seconds. And of course, it's not available in 2012 and SQL Server 2014, only in 2016 and later. Latency is actually composed of two different components. We have send latency and redo latency. The send latency is the network kind of latency, so if we're sending data over the wire to the secondary, that will be part of send latency and maybe some other overhead. And then redo latency is when the redo threads on the secondary are applying those records, those log records, to catch the secondary up to the primary. So it depends on what you're talking about in terms of latency. Do you mean just the networking part? Do you mean to the point where the data is actually available on the secondary? That's the latter one, is the one we consider latency, where we want to find out how long is it before data is available for querying on the secondary versus the primary. On the send latency, one way to calculate that is to take the log send queue size, which is available in a DM view, and divide that by the rate at which bytes are being sent. And the redo latency, similarly, has a redo queue size available, and you can divide that by the redone bytes rate as well, the rate at which redo threads are doing the byte application. Unfortunately, those columns, the byte rates would be easy to find because there are columns in the DM view, but there are serious bugs in them, unfortunately, even in 2016. I'm not sure about 2017, but I think it's probably still there. These bugs were marked as fixed in 2012 and 2014, but unfortunately they still are an issue in 2016. So we have to go the long way, the hard way, to figure out the sent bytes rate and the redone bytes rate, unfortunately. So we have to go actually to perfmon statistics on the secondary and then calculate the rates from there. Because perfmon does show the correct values for the send bytes and the redo bytes and the rates and things like that. But just for some reason the DM views don't have it. And to get those perfmon statistics, you have to actually query the secondaries. So from our monitoring standpoint, we provide the ability to monitor latency and also throughput on the secondary rather than the primary. And on the primary, we just show statuses, for example. Additionally, if you have file streams, you need to do a little bit more work to take that into account. The send queue size does not include bytes for file streams. There is a separate column for file stream send rate that's available in the DM views. However, it may, there may be bugs with that. We don't know. But there's more work to be involved if you're supporting file streams as well. And here's a query for getting the information from perfmon. So this is for getting the sent bytes and the redone bytes. And the way that the counter information is stored, these are counters that continually go up. They're not the full number of sent bytes sent from the beginning of time. There's some wrapping that goes on with the counters and things like that. But over a reasonably short amount of time, you can then calculate a rate on the sent and on the redone, and then use that for the sent bytes rate and the redone bytes rate as well. Throughput is basically a question of how many bytes is being replicated per second. So latency is how much time is it taking before data is replicated. Throughput is how much data is being replicated. And again, this is broken down into the network or the send side versus the redo side. And the rates are just the ones we calculated for latency, the sent bytes rate, the redone bytes rate. So maybe it's sending a few gigabytes, a few hundred megabytes per second, or maybe it's applying a few hundred megabytes per second on the redo, things like that.
So what you're doing is you're actually measuring how long it takes to move everything from where you from the log file into the other side and get the disk.
Right, that's the latency, and so then the throughput is how much are you pushing through that pipe.
Right.
So it's the total amount. So yeah, that's both.
It's never unlimited, although we'd love it to be.
Yeah, exactly. So now on the redo side of things, as we said, there's a sent side and a redo side on the latency and on the throughput. On the redo side, if there is a bottleneck on the redo apply, we can get more information on the redo threads. We can look at CPU information. We can find out if it's being blocked for some reason because maybe a DDL statement or something is blocking the redo thread from applying log changes. So we can look at blocker information, disk I/O information, other types of statistics for the redo threads. The redo threads on the secondaries are actually started and stopped on demand for each database. And so they'll start up and then they'll quietly go away after a while. Rows in the DM exec requests DM view have information on the redo threads, and they're the ones that say command equal db startup on there. Now, there are other types of scenarios where you might have a db startup item in DMX exec request. So to figure out which ones are applied to AG in particular, we need to also join against sys databases on database ID and look for replica ID is not null and those kinds of things, just to narrow it down to only the AG-related redo threads. But this is a great way to find out if you think the redo threads may be the bottleneck and why it's, maybe there's a very low redo bytes rate, for example. This may be an issue and you can examine on each secondary. And here's the query for doing the redo threads on the availability groups. Appreciate if you could mute your line if you're listening, please. Thank you. So here's a query for redo threads on AG. You can see here we're getting information on blocking sessions that may be blocking because of a DDL command or something like that. We have wait information, wait time, wait resource, CPU time, physical reads, logical reads, writes. So lots of information for why the redo thread may be a bottleneck. And then we can also query the status of items, of replicas. So on the primary, we could run this kind of query right here to see the different replicas, their roles, whether they're primary or a secondary. We can see the status, which will be like online or some other status, and then also the connection state. Now the connection state is important because the way that AG replication works, it's not a push mechanism, it's a pull mechanism. The secondary databases actually have to, the secondary replica, excuse me, actually have a thread that actually calls into the primary area and say, okay, hey, I'm ready. Now somebody start sending me some data. So it's much more of a pull mechanism. So when the connection goes down, this is something you need to monitor in order to see, okay, I don't want to alert, for example, on a bunch of problems with secondary databases when I know my connection to the whole replica is down. So the connection is definitely the first thing that has to be there before you can start talking about whether the secondary databases are okay or those kinds of things. So that's a very important thing to monitor as well.
So you kind of write some logic that says if main connection is down, then.
Right. Or if it's not down, you want to see, if the database status is bad, then we want to alert on that.
Sure.
And that's
so
something
are there any questions from Eric or from Alpesh?
No. I just joined in.
Okay. Eric, any ideas? Okay. Maybe you're on mute. Anyway, okay, so we're at the demo point.
Yeah, feel free to interrupt anytime. So surveillance takes into account all those things that I mentioned, and we'll see more of that alerting on that side as well. So we'll go ahead and switch over to the product. And so now hopefully we'll be seeing a nice big blue background on there as well.
We are.
Okay, so we'll go ahead and launch our web client for Bradmark surveillance. And we're going to take a look first at some availability groups, and then we'll take a look at a little bit more generic functionality of surveillance. Okay, so we'll go ahead and log in through the web client. Oops. Let me get my password right. Okay, so here we are. We've logged into what we call our central alert server, so I can actually seamlessly browse the lots of different other servers available on our network. And I'm going to go down to one particular satellite server that has SQL Server monitoring going on. But you can see the various other agents like our alerter agent, our analyzer agent, our repos agent, OS collector, and those kinds of things. This is for SQL Server. And I'll go ahead and take a look at one of my primaries. And you can see here we have a list of views that come up. These are database connections, or what we call our entities. And when I click on it, I get a list of different types of views that show real-time monitoring and things that I can also flash back as well. And so we'll go ahead and take a look at availability group health on the primary. And we can see that this particular primary, we have two different availability groups. We have a bad availability group, which is bad right now, and then we have another sample one, and we click on this, and we can see the various replicas that are available, the two secondaries, our primary, whether it's connected or not. And this is a lot of our grids here we can copy to a clipboard. We can save it off to a spreadsheet. I can search for certain things, so if I want to look, for example, only at one particular one, I can go ahead and search for that as well. And here we have a lot of different replicas over here. We also have AG listeners that are available. And you can see here we have an AG listener listening on this particular DNS name, which is different from the SQL Server instance names. We can see how many read-write sessions are going on. There's something called conformance, it's a technical thing regarding the way that this relates to Windows clustering. We can see what port it's listening on. And if you have multiple listeners, that would also show up here. Many sites will have multiple listeners for redundancy and other reasons, for subnets and things like that. So those are all available here. And of course, a lot of the things that I'm showing you right now can be alerted on, as we'll see also in a little bit. We also can see the actual primary database replicas. So these are the three databases that are part of the sample AG group that are being replicated, and you can see right now these are the ones on the primary, and they're healthy at the moment. So this is an overall health view of it, and now we're going to go over to one of our replicas. I actually have a connection to another replica on here. I'll go ahead and bring up a replica on here, but before I do that, I'm just going to go ahead and start a little bit of activity on it so we can see a little bit of what's going on. Okay, so we'll go ahead and take a look at a replica. Secondary replica, I should say. And so here we have, this is part of the sample AG availability group, this particular replica on this particular server. This is the O2 server. And you can see at the top here we have the different databases, secondary databases. We can see latency when it refreshes here. Let me go ahead and do a refresh here. You can see a couple of things that are going on. Right now, it's the activity hasn't quite posted through yet, but you can see the latency timing. You can see the sent bytes per second, the redone bytes per second. So this is the throughput broken down by sent and redo. The last time any message was sent through the system, the overall health of the replica, if it's synchronized or not synchronized, if it's failover ready on here. It also has a check mark, so you can see immediately whether you can fail over or not. If it was suspended for some reason, the suspend reason is on here, and other information, latency breakdown as well. You can see on the latency, now we've gotten a refresh here, we have 43 milliseconds of latency overall, and that's broken down into 7 milliseconds on the redo side and 35 milliseconds on the network side, so mostly network, and it's not very much latency anyway. If we click on this, we can actually see graphs showing the latency going back a little bit. Now we just started the activity here. We were kind of flat for a while. You can see we had 0 on the throughput, and now we're starting to get a little bit of throughput here. We'll see this as it starts populating, and you see the latency starting to go up. We had very good latency earlier, and now it's starting to go up a little bit. There's a logarithmic scale on the latency, but you can see back a little bit of time. You can also scroll this graph as well. You know, I can scroll here. I can scroll out on the graph. I can scroll in. I can scroll back and forth a little bit of time, as well as this entire screen can actually be flashbacked as well. I can actually come over here to flashback if I wanted to, and say, okay, I want this particular day, I want to go back to this time last week at this particular time, and then I could tell it go, and it would take the whole UI back in time to that particular time in the past for, let's say, a few days ago or a few weeks ago. But right now we're just interested in the real time at the moment. And we have the latency, we have the throughputs, we have the queue sizes. You can see as the send queue is growing and the redo queue is growing as I've started activity. And of course also the last time that a message was sent. So if there was a problem, a really bad break in the replication communication, it may be a very long time since the last message was sent, and you would see that as a delay in your replication. So a lot of great information to show you the latency and the throughput for an availability group being replicated to a secondary, as well as we can also see the redo thread information that we mentioned earlier. You can see that we have the redo thread on the SalesDB database, and we have this amount of logical I/O and physical writes and CPU. So not a lot of resource usage at the moment. No blocking scenario going on right now. It's just cranking along doing its thing. But as the activity has been going on, you can see our latency has grown from initially 43 milliseconds up to 2 milliseconds, 2 seconds, and the send bytes going up to 3 megabytes and those kinds of things. So a little bit of activity backing up on the system as it's being a little bit overwhelmed in this particular activity. Any questions so far?
I think Eric's muted.
Okay.
Hey, John, do you have any questions?
None.
None, okay.
Okay, so as I mentioned before, we can alert on a lot of these things as well. We'll go over to the types of alerts that are available. Some of the things, if I search for AG-related alerts, you can see I have a lot of alerts available. This is our flat dashboard where I'm seeing a lot of different types of alerts going on. I have a lot of different problems going on in my particular environment. But if I search for some AG-related ones, you can see here that we have alerts based off of things like if a particular secondary database is not joined up, if we haven't received anything in a while on a secondary database. So there's a delay going on in the replication. That's also available. And we also have alerts based off of if the other types of delays and latency and other types of delay, too much throughput, those kinds of things are all available as alerts as well. So a lot of different ways you can do this. And when you do have something like this, you can also come directly into here. Let's say you get an alert from a particular problem going on. We can actually come into here from this view. In addition to being able to close out the alerts and being able to export it as a spreadsheet, those kinds of great things, you can also jump directly to that window for that alert. So in this case, I have an alert that came in for some SQL that was running a long time, and I can go ahead and jump directly to that window that's going on. Okay, I think at the moment it's not it's not jumping up to that window for some reason. But basically, you can jump directly to that window and see more information and dig down into it, do flashback, do other kinds of things as well. We see here we have some database ones. Let me see if I can open up this one here. And you see here we opened up a database window to this particular database, and this is going to take a moment here to populate on here. And you can see we had an alert on a database having a problem, and then we can jump directly to a view showing databases in SQL Server. And you can see here that we have different types of databases. We can see the file usage on each database, how much is allocated, how much is used. We can see the types of file group usage that's going on. So if you're using file groups, you can see the breakdown using that as well. We can see information on log reuse weight, other types of information about blocking scenarios and other space usage problems, and those kinds of things are available. You know, with SQL Server especially, you have space usage that can expand with the drive, for example. So it's not limited; it's only limited by drive space or SAN space or something like that. We take into account all those different types of scenarios, and we can help you figure out, for example, if you're running out of space at the OS level, in addition to at the database level, for example. So there's a lot of more information for helping to diagnose if you got an alert, for example, on low database space or a blocking scenario or a bad status on a database. Then you can also drill down for more information as well. So let me go back over here again. We'll try take a look at the events over here as well. So here are the types of events that you can set for our SQL Server product. And if we take a look at AG-related ones, you can see we have alerts that can be generated for latency, for if things are joined or not, if you've ever received a message, if there's a suspended database, if there's an unhealthy database. SQL Server has a nice one status thing called healthy or unhealthy for a lot of aspects of availability groups. So we can also monitor that as well. Whether replicas are disconnected, as I mentioned before, the fact that it's connected is an important thing to monitor on availability groups. And that's in addition also to our other types of alerts on database usage, to SQL, to disk I/O, and those kinds of things as well. As I mentioned before, we can also take a look at alerts by different types of organization. We can take a look at alerts by server. So here we have several different servers that are being monitored. I have a couple of problematic ones, and if I click on that server, I can then see all the different types of alerts, all the problems I'm having with that particular server. And we can also take a look at this by database as well, what we call our entities. So we can also take a look at it, more fine-grained look at it as well. In addition to the availability groups monitoring, we also have various other views that are available for SQL Server. A lot of our databases that we monitor in our product start out with a health window, and this provides kind of an overview of what's going on with the whole database. And just taking one moment here to bring up here. I have a little bit of a slow system, but it should come up here in just a moment. And in addition to, you can see here on the other windows we have process information, we have active lock information, blocking scenarios, currently running SQL. We saw the databases window, long-running statements, system settings are available. So a lot of different views to see what's going on. But the overall health window, I have one broken collection here at the top, unfortunately. But you can see we have an overall view of what's going on with the system. We have fullest database groups, fullest log groups, CPU information. And again, these graphs are scrollable. You can zoom in and out as well to see what's going on. So for example, here's over a several hour view of the CPU, and then tempDB storage as well. Right now we actually have a blocking scenario going on, I believe. If it hasn't cleared yet, let's see if there's a blocking scenario going on. Okay, well, I think I'm having a little bit of an issue on this particular system at the moment, but it's basically a lot of different views are available for seeing currently running SQL. You can then drill down to see the SQL text and more information on their process level as well. We can see the I/O and those kinds of things broken down by writes versus reads and those kinds of things. So a lot of different information is available in addition to the alerting. And then we also have more long-term reporting available as well. That's available through the web client using much of the same types of screens that you've seen here on the real-time are available for our web reporting in addition to any types of queries you want to do against a central repository database.